Hello everyone. How do sandstorms on Mars compare to Earth's? Let's find out. When we envision storms on Earth, we might picture towering clouds of swirling dust, powerful desert sandstorms, or perhaps even the fury of a hurricane. Yet, there's another planet within our solar system where storms take on a whole new dimension: Mars. The red planet is notorious for its colossal dust storms, dwarfing anything we experience on Earth and shaping the very Martian landscape itself. Let's dive into a comparison of these incredible phenomena to understand the scale and power of Martian sandstorms and how they differ dramatically from their terrestrial counterparts. One fundamental difference stems from the distinct atmospheres of Earth and Mars. Earth's atmosphere is dense and rich in nitrogen and oxygen. In contrast, Mars possesses a remarkably thin atmosphere composed primarily of carbon dioxide, with an atmospheric pressure less than 1% of what we find on Earth. This thin Martian atmosphere plays a crucial role in enabling the formation of such vast storms. On Earth, strong winds can whip up and transport dust or sand particles. However, the density of our atmosphere acts as a limiting factor. The thicker air creates drag and dissipates energy relatively quickly, influencing the size and duration of terrestrial dust storms. On Mars, the low-density atmosphere offers far less resistance to moving particles. Once Martian dust particles are lifted into the air, they can be carried over great distances far more easily, contributing to the potential for enormous, expansive storms. Furthermore, Martian dust has unique properties. The fine-grained, powdery dust on the red planet is the result of eons of weathering and erosion. This dust is electrostatically charged, meaning the particles tend to cling together. When lofted by winds, these clumps can further enhance the potential for a small dust storm to grow exponentially as it spreads across the Martian landscape. While local, regional, and even planet-encircling dust storms occur on Mars, the triggering mechanisms aren't perfectly understood. Scientists know that variations in solar heating, particularly during transitions between seasons, contribute to temperature differences across the globe. These temperature changes can lead to atmospheric circulation patterns and strong winds that have the potential to initiate dust storms of varying scales. Additionally, the unique topography of Mars, with its towering volcanoes, deep basins, and craters, creates localized wind patterns that likely play a role in how and where large storms develop. When a Martian dust storm kicks up, it's a sight unlike anything we could witness on Earth. Imagine a storm system that can blanket an entire region, or in some cases, engulf the entire planet in a swirling haze of dust. These vast storms can last for weeks or even months. During particularly strong global dust events, fine dust particles get lofted high into the Martian atmosphere, where they can take a remarkably long time to settle back down to the surface. The impact of Martian dust storms extends far beyond obscuring our view of the planet's surface. These storms can significantly affect both robotic and potential future crewed missions to Mars. During a large dust storm, the amount of sunlight reaching the Martian surface can be drastically reduced, posing a challenge for missions relying on solar power. Fine dust can infiltrate machinery, clogging instruments, and potentially compromising delicate electronics. For human explorers, dust storms would force changes to operations and a focus on protecting habitats and equipment, particularly during extravehicular activities. Beyond the immediate challenges, Martian dust storms might have an even more subtle impact on future Mars colonies. The ever-present dust, with its potential electrostatic properties and the possible presence of reactive chemicals like perchlorates, holds the potential to create unforeseen long-term challenges for both human health and the equipment vital for survival on Mars. While Martian dust storms are a force to be reckoned with, it's crucial to remember that they also play a vital role in the ongoing evolution of Mars. Dust storms are a major method of reshaping the Martian surface, transporting material, eroding rock formations, and altering the landscape over time. The very distribution of Martian dust itself paints a picture of the history of these winds and the atmospheric processes they reflect. The comparison between the sandstorms on Mars and Earth extends beyond the realms of pure science, highlighting the adaptability of natural phenomena within vastly different environments. They drive home the fact that while we share commonalities with our planetary neighbor, dust storms being one of the specific conditions on each planet have sculpted these events into dramatically distinct forces. Understanding Martian dust storms is essential for planning long-term, sustainable missions to the red planet. The solutions developed to mitigate their risks, from advanced filtration technologies to dust-resistant materials, could have invaluable applications here on Earth in fields ranging from air pollution control to sustainable agriculture. As we relentlessly pursue our exploration of Mars, unraveling the mysteries of its colossal dust storms is not just about expanding our knowledge of another world. It's a pursuit that promises to deepen our understanding of our own planet, push the boundaries of technology, and bring us one step closer to unlocking the secrets of surviving in the most extreme corners of the cosmos. Thank you for watching. Please follow for more related videos and see you later. Goodbye.